Okay, now in this scene I want to show you some results of some testing of passive components. So we're going to start with a fairly simple one, the resistor. And of course none of our components are ideal resistors or ideal anything. So this graph can show us something about how this component performs. So what we did is I decided that I was going to test the thing from a start frequency of 100 Hertz all the way up to 10 megahertz. And using the probes that come with your Cleverscope in circuit A, if I use probe correction, what I can do is I can get some fairly good results all the way up to 10 megahertz. So what I have here on my Z under test right here is a 1K leaded 5% metal film resistor. So here's the results that we get when we subject this thing to the test. So first of all, the resistor's impedance or resistance is shown in red. And it's supposed to be a 1K 5%. So we can see here from the graph that from 100 Hertz all the way out to right about 2, 3, 4, 5 megahertz, it's within spec. So that's pretty good. In fact, it's even within spec out to here because it goes down to 1,000 ohms right there. Now, on the other side, we've got the phase. We'd expect phase to be 0 through a resistor. So we can see that for the most part it is. And the phase starts to go up as we go higher in frequency, and we'd expect that because it's a leaded device. So there is some lead inductance that's coming into the picture here. But the other thing that's probably more important is the ground leads on the probes are causing most of what you see here. So one of the things that Cleverscope is doing is that they're developing some test fixtures that can help people get better results and eliminate things like the loop inductance and so forth that you get with the little ground leads. And so those are in progress, and they're keeping me informed as to when those are going to be available for sale. But you know, this is the simplest example of just showing you how this works. So what we've done is, just to recap, is we've put in our start and stop frequencies, the amplitude that we used, which was about 1 volt, no offsets, etc. We're using narrow band sweeping, we're interpolating the plot and so forth, and we're using the setup as in reference A, or schematic A, and our reference is a 50 ohm precision resistor that we use there. So while the unit is actually sweeping, one of the things that we like to watch over here is the scope display itself. And because you'll be able to see the excitation and response waveforms come through on this as this is actually running. That's an important thing to keep your eye on while you're doing it.